I'm going to introduce our digital stethoscope, which can simultaneously auscultate multimodal physiological signals by the following 6 aspects. The COVID-19 epidemic has brought a heavy burden to the public health worldwide, especially in the respiratory system. In addition, according to the statistics of the World Health Organization, the top 10 diseases in the world in terms of incidence rate and mortality are shown in the right figure. COPD and lower respiratory tract infection are in the third and fourth places, respectively. The above facts clearly remind us that lung disease is a major threat to humanity, so we need to pay more attention to the diagnosis and treatment of lung diseases. Furthermore, with the rapid development of artificial intelligence, it's also an increasingly urgent public demand to develop a miniaturized, low-cost digital stethoscope system, which can simultaneously auscultate multimodal physiological signals to achieve the monitoring and the diagnosis of heart and lung diseases. This figure shows the Axel digital stethoscope system developed by our team to solve the above problems. In the developmental process of stethoscope market, there are 3 different stethoscopes: traditional stethoscope, traditional electronic stethoscope, and the digital stethoscope. They all have high accuracy. In contrast, Axel has some obvious advantages, as shown in this slide. The system includes 2 parts, data collection and data analysis. The data collection part is composed of the shell, electrode sensor, and PCB. The shell adopts a pear-shaped design. The size conforms to ergonomics and it's easy to hold. The carton style can also reduce children's fear when examined. We choose the contact type to charge the stethoscope, which is convenient. We also choose contact electrodes and microphones to collect signals to reduce signal noise as much as possible. Finally, PCB digitizes the collected multimodal signals and then transmits the signals to the mobile terminal through Bluetooth to analyze and display the data. The data analysis part contains real-time ECG and real-time lung sound analysis. When collecting data, the app page will synchronously display the electrocardiogram and the lung sound curve. After the collection, the cardiopulmonary data and the analysis results will be stored in the cloud server, which greatly facilitates remote consultation and reduces the threshold of use. The hardware architecture of Axel is shown in the figure. After the microphone and ECG sensor have collected cardiopulmonary sound and ECG, they transmit the signals to amplifier. Because the frequency band ranges of pulmonary sound and ECG signal are different, in order to achieve simultaneous processing, we use analog to digital converter with different clock frequencies to convert the signal. And the digital signal obtained will be transmitted to DSP for filtering through time division multiplexing. So far, all data processing is completed. The mobile terminal of Axel refers to an application that has deployed data analysis algorithm. We can get data analysis results more quickly and intuitively by the mobile terminal. After the mobile terminal receives the data through Bluetooth, it will firstly pre-process the audio as shown at the bottom left, and then input the processed spectrogram into our lung sound classification model to classify the respiratory cycle. The picture on the right describes the architecture of the classification model. As can be seen from the frame diagram, the spectral diagram will pass through multiple ResNet modules, and the residue connection avoids the problem of gradient disappearance on the premise of deep extraction of time-frequency characteristics. We also inserted AA ResNet with attention mechanism between the concatenated ResNet, which improved the learning ability and accuracy of the model for global features. We have conducted experiments with ICB-CHI dataset. The table in the figure compares the sensitivity, specificity, and the score of our model with the world's advanced model. From the table, we can clearly see that our model can effectively improve the score on the premise that the sensitivity and the specificity are basically consistent with the world's advanced level. The paper related to the model has been accepted by Physical Measurement Journal. To verify the function of the system, we built a test platform as shown in the figure. First, place the Axel at the chest position, and then operate the mobile terminal to collect the data and wait for the analysis result. After the data analysis is completed, click to view the measured heart rate and the electrocardiogram and lung sound analysis results. We have also realized the anomaly detection function. If the user's heart rate or lung sound is detected to be exceed the normal range, we will choose whether to call for help automatically according to the feedback of the user. Watch the next video please to see how to use our stethoscope. This is a digital stethoscope device for simultaneous auscultation of multimodal physiological signals. The device consists of 3 parts, which are printed circuit board, electrodes, and sensors from top to bottom. Now we will show the process of measuring heart and lung sounds and ECG signals using our device. Place the device on the chest, select a device and start measuring. Wait for the collected data. Click the End Measurement button after 30 seconds. Wait for the analysis results. Click to view lung sound analysis results. Now the measurement process is completed. When it comes to digital stethoscope, there are already some mature products in this field, but Axel's goal is to strive to be the first choice of users. Some people may ask, why are you so confident? Next, we will answer this question with 3 more. First, Axel is a more reliable product. As a child stethoscope, in addition to heart and lung sounds, Axel can also collect multimodal physiological signals such as ECG and body temperature. Compared with the same type of products, Axel's function is more complete. The design of the shell fully takes the various needs of users into account. In addition, we have been cooperating with Shanghai Children's Hospital, which also has a high rating on Axel. As a general stethoscope, the lung sound classification algorithm adopted by Axel has a higher accuracy, so as the system. The average price of digital stethoscope in the market is about 1,513 yuan, while the estimated price of a set of Axel stethoscope is about 200 yuan, which is only 13% of the average market price, so it's cost effective. As an assistant of doctors, Axel has higher reliability in technology. In terms of application, it can be used in a variety of application scenarios, such as clinical diagnosis and treatment, physical examination, and disease tracking. Second, Axel can provide more diversified services. Our target users include doctors and patients. We will provide hierarchical services according to the needs of different users and truly achieve service classification and object-oriented. Through mobile terminal, Axel has built a remote communication between doctors and patients, providing great convenience for remote diagnosis and treatment. After Axel is put into application, we will make the collected data into open source database in a legal way, so that both algorithmists and medical workers can use our database for relevant research. In addition, service implementation is also the focus of our attention. In the next few years, we will set up offline service points in elderly communities and other places, and provide medical services such as auxiliary physical examination regularly, so that more people can monitor their health. Third, Axel has more social value. Axel can be used for remote diagnosis and treatment, thus reducing the risk of disease transmission. Our database can be used for teaching and research, and it's convenient for remote multi-expert consultation, thus promoting the solution of professional problems. Finally, the purchase threshold and the use threshold of Axel are very low, which is very suitable for people who are difficult to access professional medical care, thus alleviates the problem of uneven distribution of medical resources. So far, our team has carried out optimization for Axel for many times. In terms of hardware, we make the PCB lighter by reducing the area of the PCB and using button batteries. FPGA is also added to realize data encryption and preliminary signal analysis. We add a contact time charging base in the shell so that charging is more convenient and fast. In terms of software, we add data decryption module and the display of hardware analysis results in the app. Through a large number of experiments, the accuracy of our cardiopulmonary sound hybrid 6 classification algorithm has also been greatly improved. Next, we will continue to optimize the Axel system from both hardware and software aspects. and achieve OTA, firmware update, and real-time sound playback while striving to improve system accuracy and speed. This is our team's brief conclusion to the project of digital stethoscope that can collect multimodal physiological signals. Thank you for listening.